So there's some dogma that needs to be addressed again with reference to comets, what they actually are. Um, of course, we have a very alternative viewpoint on comets, and as worked out with stellar metamorphosis, it's different than the mainstream's version, and it's also different from Electric Universe. As you'll see why in a second here. I have this book, Comets, Visitors from Deep Space. This is written in, or copyright in 2013. It says here, what are comets? Hi, Celeste. I know you're out doing a thing right now. The universe is a dynamic, active, and often violent place. Stars, planets, and galaxies undergo rapid change, constantly worked on by their environments, or slow change, to be honest with you. Seeing Earth, the Sun, or the Milky Way as it was long ago is not possible. Comets, however, give astronomers a precious storehouse of ancient information. They are relatively pristine, ancient blocks of ice that allow us to peer back in time. There are a few things wrong with this statement. For one, most of the objects in the universe undergo very slow change. So the idea that things are rapidly changing all over the place is, well, it's not necessary. You can understand the majority of the universe's processes using a very slow mentality, a very slow time scale. Two, it says here, seeing the Earth, the Sun, or the Milky Way as it was long ago is just not possible. That's true, you can't see the Earth as it was long ago. You can't see the Sun as it was, but you can infer it using the general theory. And I don't know, David J. Eicher, I don't know if he's aware of this theory, but I'll go ahead and teach it to him as well if he's watching this video. The Earth is about right here. Seeing the Earth as it was very long ago, it was sun-like. And seeing the Sun as it was long ago was a blue giant, as well as it was a very bright planetary nebula when it was being born. So we can see young suns, we can see young Earths, and we can see old Earths, and we can also see the interiors of these objects because they impact each other and they basically excavate each other. I'll get into that in a second here. It also says here, comets, however, give astronomers a precious storehouse of ancient information. That's very true. Comets do give us a storehouse of ancient information, but it's not in the way that David J. Eicher and the mainstream have it. Comet information, comets are asteroids. They're the same things. The reason why they call them comets is because they have incredibly elliptical orbits and they interact with the solar wind differently than a regular asteroid does. Even though asteroids have mostly circular orbits, comets, they have very, very highly elliptical orbits. So there are electrical processes that happen on the surface of the comets that give them those huge comas. If you take any asteroid in our system that's labeled asteroid and you give it a hugely elliptical orbit, it's going to become comet-like. It's going to be called a comet. But comets and asteroids are the same things. The only thing that differentiates the two is the asteroids do not have highly elliptical orbits and comets do. That's the only difference. So to say it's a big chunk of ice, it's misguided because comets are asteroids. The three main classes of asteroids are C, S, and M types. The C or chondrite types are most common. Probably they consist of clay and silicate rock and are dark in appearance. They're among the most ancient objects in the solar system. That's correct. They are clay and silicate rocks, but the reason why they're clay, silicate rocks, and various other materials, because C-type asteroids are excavated from the surfaces of very highly evolved stars. They are when another object impacts it, that material is excavated and ejected outwards. That's what forms. That's where asteroids come from. The ones that can stay together after the impact event. So you have a large object impacting another object, and you have spellated material, which then is ejected outwards. And depending on the size of the impactor and the velocity and the size of the impacts, the object that has the impact site, will determine how much material can be excavated and how much of it is broken up and all that. So there's a lot more to it than what meets the eye. But essentially, the idea here that he says, or that on this NASA website, is that chondrite, the C-type asteroids, are the most ancient objects in the solar system. That's false. The most ancient objects in the solar system are the objects that formed first. And the objects that formed first, I'll get to those in a second. The second type are the stony type, which are made up of silicate materials and iron-nickel material. So when the star is differentiating its interior, in the center, you have your silicate or your stony and iron-nickel material. Those are the S's. And then the M's are pure iron and nickel. So basically, these are the most ancient pieces of ancient stars. The M type, which are mostly iron and nickel alloy. Because of the very center regions of highly evolved stars that have been broken up over many trillions of years. And the core of the star is the object that has formed the very first structure inside the star. So for those who are new, when a star evolves and it cools and dies, it forms its interior with the purest iron nickel first, which then forms the inner core, and then it layers material on top of it as its outer atmosphere is shed away and all the hydrogen and helium is lost, and the main elemental composition of the star gets heavier and heavier, and the molecules form and eventually life and all that good stuff. But yeah, there's C, S, which is stony and iron, and then you have your pure iron and nickel asteroids. Now, as well, it's good to note that there are many of these objects, and that should be pretty obvious, because there are lots of opportunities for objects to slam into other objects in the galaxy over trillions of years. You have all these rocky objects. Sure, there's lots of space involved, but every now and then you get a good collision. Now, I would imagine it would be something like this. And you see how these two much smaller moons will be slamming into each other. Even if they were to graze past each other, it could spall off even more material. But you have these huge bits of material being ejected outwards. These are where the asteroids come from. These are where the meteors come from. Meteors that hit the Earth's atmosphere. They come from ancient collisions of two pre-existing bodies. The material composed of two very, very, very old objects that are slowly disintegrating and slamming into other objects as they move about the galaxy. And of course, they're traveling at extreme velocities. So when you have something the size of Vesta slamming into another Vesta-sized object, sure, it's probably really rare for that to happen. But I can guarantee you, if they travel each 50,000 miles an hour each, when they slam into each other in the vacuum, there's going to be a huge explosion. It's going to be pretty magnificent. And there's going to be a lot of shrapnel from that explosion. And that shrapnel is what enters into the Earth's atmosphere and gets recycled back into the star's interior. And the star recycles this material, collects it all back up, and the process repeats as the star, cools and evolves over many billions of years, eventually becoming smaller and smaller. It then eventually slams into other objects, creating lots and lots of smaller objects that are many hundreds of trillions of years old. So essentially, that's what comets are. I know there was one comet that passed by, I can't remember its name, that everybody could see, but that's what that thing is. It's the remains of an extremely ancient dead star that's still wandering around and hasn't been quite absorbed by another hotter host and absorbed into its interior. But one day that object is going to slam into another hotter, younger star, or maybe even an old one, but it will be absorbed back into here and it'll be recycled back into the interior, and it will be as if it never existed as an independent body. So that's really cool. And keep that in mind when you see astronomers and they talk about comets, they talk about asteroids being really ancient. They are ancient, but it's not that they're ancient in terms of the sun formed and all the planets around the sun formed all at the same time. They're ancient in terms of those are the remains of ancient stars that have evolved over many billions of years, that have eventually disintegrated over even trillions of years. So they're far older than what the astronomers are claiming they are, and they're far more impressive. To correct NASA on their asteroids and comets and meteors page here, I took this from. They have here, asteroids, sometimes called minor planets, are rocky remnants left over from the early formation of our solar system about 4.6 billion years ago. That's completely false. Asteroids are the remains, pieces of the remains of ancient dead stars, and that's the big revamping of our worldview that's going to have to occur over the next couple decades. I just happen to be one of the first people that should, bring this to light and, share it with the world. All right, guys, I think I made this talk long enough. Later.